Hello students, today we are going to discuss operational amplifier. What is the difference between amplifier and operational amplifier? What is amplifier? Amplifier is nothing but raise the strength of the weak signals. Suppose a small signal or weak signal, suppose this is an amplifier. Amplifier, suppose if you are giving the input, then we will get the output. So suppose the input is your some millivolt, like suppose 0.2 millivolt, and output is some volt, that is your 1 volt. Let's say, what does mean by amplification? The strength of the range of the weak signal by means of how many times the output will be amplified from the input is nothing but amplification. So output by input. So here there is an amplification factor, that is your output by input. Suppose if your output is 1 volt and input is your 0.2 millivolt, that is 1 by 0.2 millivolt is nothing but 1 by 0.2 into 10 to the power minus 3. It is around 10 to the power 3 by 0.2. That is your suppose if it is 10 and if it multiplied with 10, that is your 10 to the power 4 by 2. So it is around 5000. So output is 5000 times the input signal. So that we call as the amplification of the input signal. So it is all about your amplifier, that is your common bipolar junction transistor or field effect transistors. So can do this. So what is the difference between amplifier, common BJT and operational amplifier? So in case of operational amplifier, so it is the beauty of this operational amplifier is what? So that is, here there is this is a symbol of operational amplifier, or we short form we can say that op amp. In operational amplifier op amp, so that it is having two input and one output. So here there is an minus terminal and this is your plus terminal. This input we can say that inverting input, and this terminal, this input is called as the non-inverting, and this is your output. So in case of operational amplifier, it has two input terminals. One is inverting terminal, that is your negative terminals. Another is your non-inverting terminal, that is your positive terminal, and another one is your output terminal. So in common amplifier, what does it means? We can raise the strength of the weak signal by means of what? Amplification factor. So how many times the output will be amplified from the input is nothing but amplification. That is common device, electronic device, that is your transistors, bipolar junction transistor, field effect transistor are electronic devices which can raise the strength of the input signals. But in case of operational amplifier, there are so many applications of operational amplifier, that is your op amp. So in case of operational amplifier, it has the following advantages or characteristics of the operational amplifier. First of all, we know what is the characteristics of operational amplifier. In characteristics of operational amplifier, in case of characteristics, as far as operational amplifier is concerned, there are first number one characteristics is your what? That is your input impedance. Input impedance is infinite. Input impedance is infinite. And number two, output impedance is 0. Gain is infinite. And number four, CMRR. One is of the operational amplifier is your common mode rejection ratio. CMRR is too high. In ideal case, it is infinite. All we are considering infinite means of what? In case of ideal case, In ideal case, input impedance is infinite, but practical case is not infinite, it is so high. Another gain is infinite. What is gain? If we'll say, if we will consider the output is your V0 and input is your Vd. Here Vd means what? If there are two inputs, one is your inverting and another is non-inverting, difference between the two terminals or difference between the two voltage is the Vd. So difference voltage. If I will say, suppose this is your LED V1 and this is your LED V2. V1 is the input to the inverting terminal and V2 is the input to the non-inverting terminal. The difference between V1 or the inverting and non-inverting terminal is your Vd, and V1 minus Vd, here Vd is nothing but V1 minus V2. So one of the important case is what? In case of operational amplifier, there are so many characteristics of operational amplifier. First, these two characteristics is very much important. Input impedance is infinite, output impedance is 0, gain is infinite. Using three characteristics, you can do so many problems related to the or numericals related to the operational amplifier. If you appear the GATE and IS examinations, there are one or more questions will come from the operational amplifier. There are so many varieties of application of the operational amplifier, and how will you solve the numericals related to the operational amplifier? The basic thing is you must know the three parameters, three characteristics. First, number one characteristic is your gain is infinite, and input impedance is infinite, and output impedance is 0. There are so many properties of the operational amplifiers are there, like common mode rejection ratio, slew rate, and offset voltage. There are so many things are related to operational amplifier, and we will discuss later on. But as far as a common application of the operational amplifier, you must know the three parameters, like input impedance is infinite, output impedance is 0, and gain is infinite. First of all, you understand, in case of operational amplifier, there are two terminals, one is your inverting, another is your non-inverting terminals. Because minus terminal is we can consider as inverting terminal, and plus terminal we can consider the non-inverting terminals, and this is your output voltage V0. So here in case of operational amplifier here, so that is, this is your minus terminal and this is your plus terminal. And here in plus terminal, there is we can consider as grounded here, and here there is your voltage, and this is your output voltage. So commonly this is your difference voltage. Already I told you, Vd equal to this voltage minus this voltage. Vd, this voltage minus this voltage, that is your Vd, difference voltage Vd. So we can say this is your V0. Gain is infinite. In ideal operational amplifier, gain is infinite, but practical operational amplifier, the gain is not infinite. If I will say the gain is nothing but what? That is your what? Gain. Suppose in symbolically A suffix B, that is your output voltage by input voltage. Output voltage V0, input voltage Vi. So V0 by Vi is your gain, voltage gain. Gain means generally we will consider the voltage gain. In gain, output voltage by input voltage V0 by Vi. You might have so many questions in your mind. So any circuits, we generally we can consider the negative terminal is grounded, but in case of operational amplifier, the positive terminal is grounded, and that ground is called the virtual ground. That is called the what? Virtual ground concept. Virtual ground. What is virtual ground concept? In virtual ground concept, so any electrical circuit or might have electronic circuits, generally we are grounded the negative terminal, but in case of operational amplifier, the positive terminal is grounded, and that ground is, and we can say that this is your virtual ground. Why we say that the plus terminal is ground, virtual ground? Already I told you, one of the important properties of the operational amplifier, the gain is infinite. The gain means output voltage by input voltage. Here, if I will say the this voltage, let that is your V0 by Vd. If the output voltage by input voltage, this voltage is nothing but your Vd, and the difference voltage must be what? If this is your infinite, if this is your if this is your infinite, if this is your infinite, what? If this is your infinite, means what? That is your what? Something by what? That is infinite. Something by this is your zero. If this voltage is zero, then gain becomes infinity. If VD is zero, how will get VD is zero? Because this voltage minus this voltage must be zero. If this voltage minus this voltage means what? Suppose this is your V1 and let this is your V2, here say let V2. So V1 minus V2 must be equal to 0 or VD equal to 0. If VD equal to 0, then you will get the, if VD equal to 0, then you will get gain is infinite. If the gain is infinite, it is one of the properties of the operational amplifier. In operational amplifier, the gain must be infinite. It is not infinite, very high value. Practically, it is very high value. But in case of ideal operational amplifier, the gain is infinite. Using virtual ground concept, if this plus terminal is grounded, means what? Suppose if I'll say V1 is 5 volt and it must be 5 volt, because 5 minus 5 equal to 0, the gain must be infinite. This is one of the basic tricks or basic thumb rule of the operational amplifier. When you will going to solve the operational amplifier problems, this voltage difference voltage must be 0. If the difference voltage must be 0, then only the gain will be very high, or ideal case it is infinite, but practically is not infinite. So that's why in case of operational amplifier, one of the properties is your what? The gain is infinite. Another one is what? Input impedance is infinite. What is input impedance? So input impedance, symbolically I can say input impedance, that is your Zi. So in input impedance is nothing but what? That is your input voltage by input current. Voltage by current is your resistance, or resistance is nothing but impedance. If the input impedance means input voltage by input current. Similarly here, the input impedance is high. High or means what? It is infinite. If it is infinite, means what? The input current tends to 0. If input current tends to 0, then only you get the input impedance is infinite. This thumb rule or this is very much important when you are going to solve the op-amp problems. You must be kept in your mind the difference voltage must be 0. If this voltage is 5 volt, and consider this voltage is 5 volt. If this volt 10 volt, it is also 10 volt. So that's why this voltage, the difference voltage must be 0 and the gain is infinite. Similarly, in case of input impedance is infinite or very high, but in case of practical operational amplifier, if the input impedance is infinite, the input current must be 0, because what? Suppose if I will say in a operation, suppose the question is like this. Here, like this. Suppose I can say here that is your AV voltage gain. Suppose this is your R resistance value RF, and this is your RI, and let this is your VI, and let this is your VG. One of the important thing is that is your here this voltage. When you are going to solve this operational amplifier problems, you have been asked to find out what is the output voltage V0 with the value is given. So one of the key point is what? The input impedance must be infinite and the voltage gain is infinite in case of ideal operational amplifier. If this voltage you can say VD, and VD must be 0. It is very, very important. It is very, very important. VD must be 0. If VD 0, difference voltage equal to 0, VD equal to 0. Due to virtual ground concept, this is your plus terminal and this is your minus terminal. If this is 0, if this voltage is 0, this voltage is what? Not 0. VG must be 0. This is the tricks, or this is the key point, or this is the important points when we are going to solve the operational amplifier problems. Since the gain is infinite, since this is grounded here, this is 0 volt, and this potential is 0, because what? The difference voltage must be 0. Another thing is what? This is satisfied, the gain is infinite, and input impedance is infinite. In case of input impedance is infinite, the input current is 0 because this current is nothing but input current. This II equal to 0. If II equal to 0, then only you get input impedance is infinite. So that's why this is the key points. These are the thumb rule when you are going to solve the operation amplifier problems. So let us now application of the operation amplifier. This is the basic things in operation amplifier. The properties of the operation amplifier is what? Now the gain is infinite, input impedance is infinite, output impedance is 0, and these are the three main properties of the operation amplifier when you are going to solve the op-amp problems. In case of operation amplifier, one of the applications of operational amplifier. But op-amp, number one, op-amp as an inverter. Operational amplifier is an inverter. What is inverter? Operational amplifier is an inverter. Already I told you in your earlier classes that is your common amplifier, generally what? To raise the strength of the input signals. But in case of operational amplifier, there are so many applications of the operational amplifiers, like op-amp as inverter, op-amp is an adder, op-amp is an adder. And another application is an differentiator. Op-amp is an differentiator. Number 4, op-amp is an integrator. There are so many applications are there. Op-amp as an differentiator, op-amp as an integrators, op-amp as an adder. There are so many applications of the operation amplifiers. Suppose, for example, as an op-amp as an inverter. First application, inverter. What is inverter? So we need simply not increase the input signal or not decrease the input signal. Whatever input, we just inverted the input. That's what we can say, that inverting the input signal. If the inverting the input signal, that works can be done by operational amplifier. So how? Look at this here. This is your minus terminal and this is your plus terminal, and here already due to virtual ground concept, this potential is 0. Let this is your Vg and this is your let Vi. This is your feedback resistor RF and this is your input resistance, that is your Ri. Feedback means what? This is your output voltage V0 and this is your Vi. So what is inverter? First of all, you must know inverter means inverting the input signal. Output voltage can be obtained simply out V0 equal to minus of Vi. If V0 equal to minus of Vi, we can say op-amp as an inverter. So here let the current through this branch is I1 let, and current through this branch is I2 let, I2, or we can say IF, because it is a feedback resistance, so mark as IF. So due to virtual ground concept, this is 0 voltage, means this potential is 0. So Vg equal to 0 because of what? Since this difference voltage must be equal to 0, because the gain is infinite, V0 by Vd, this is Vd, so Vd equal to 0, difference voltage Vd equal to 0, which implies Vg equal to 0. This voltage minus this voltage equal to 0. If this is 0, means this potential is 0. Then another thing is, you must apply Kirchhoff's current law at this point. Apply Kirchhoff's current law at Vg at this point. So let this is your I1 and II must be equal to 0 because what? Why II is 0? Because input impedance is infinite. If input impedance Zi is infinite, which implies Vi by II is infinite, which implies Vi II is equal to 0. If this is equal to 0, that means something by 0 is infinite, II equal to 0. So II tends to 0 and this current is 0. If you apply KCL at this point, incoming current equal to outgoing current, I1 equal to IF. So I1 equal to IF. Just to apply Kirchhoff's current law at this node, incoming current equal to outgoing current, I1 equal to IF. What is I1? Current equal to voltage by resistance here. So this is one voltage Vi, this is another voltage Vg, I1 equal to Vi minus Vg by Ri. In place of I1, you can write that is your Vi minus Vg by Ri. IF, what is IF? Current means what? This potential, this wire. The difference voltage, one input voltage, that is your Vg, another voltage is V0. Vg minus V0 by Rf. That is your Vg minus V0 by Rf. Is not it? Current equal to voltage by resistance. So since the resistance having one potential is Vg, another potential is your V0, difference potential is your Vg minus V0, that is your voltage, and by resistance is your Rf. So Vg minus V0 by Rf is nothing the value of IF. Similarly, I1, how to calculate I1? This current, this potential minus this potential is a potential difference. Vi minus Vg by Ri is nothing but is your I1. So according to the properties of the operational amplifier, so Vg must be 0. Why Vg equal to 0? Repeatedly I am telling, due to virtual ground concept, the gain is infinite and input impedance is infinite. If the gain is infinite, if this potential is 0, this potential must be 0 to make the gain will be very much high or infinite in case of ideal operational amplifier. So if Vg equal to 0 and this is also Vg equal to 0, so Vi by Ri equal to minus V0 by Rf. Okay, so the relation in terms of input voltage and output voltage Vi and V0. Suppose let if Ri equal to Rf equal to R, say if you will consider this is a value Ri equal Rf equal Ra, this value equal this value, so V0 value V0 equal to minus Vi. That's why the output voltage equal to negative of the input voltage. What does it mean? The output voltage equal to negative of the input voltage. That's what it indicates that the output voltage is the negative of the input voltage and it will be nothing but an inverter. So the function of operational amplifier here is nothing but an inverter. There are so many applications we will do in the next classes. How op-amp is an summer or adder, how op-amp is an differentiator, how op-amp is an integrator, and how you will solve the op-amp related problems we will do the next class. Thank you.